During a scouting exercise, Andres leaves camp and hikes 2 miles northwest. He then turns and hikes 3 miles due north. Felicia leaves camp and plans to hike on a direct path to Andres' new position. What are the direction and distance Felicia should hike? Well, let's check this out. Let's put a little graph since we're working with a north, east, west, south system. I'm going to go ahead and label here north, east, south, west. Andres leaves camp and hikes 2 miles northwest. So I'll put him on here as red. So he goes north and west. So in the middle of north and west, we'll call that 2 miles. So that's the distance he travels there, 2 miles. And then it says he turns and hikes 3 miles due north. So we go this way, 3 miles, so a little bit longer. We'll go there and say that's 3 miles. Now, Felicia wants to meet him, but she wants to take the most direct path. Which path should she take? So what angle, direction, and distance? And so really what we're looking for is what is this angle here? That's what we're going to search for. And what is this distance there? Okay, well, I'm going to start off with what I know for a fact. Since this is northwest, I do know that this is 45 degrees here. And so I'll add this on over here, that this right here is 45 degrees, as well as 45 from there. But I know that's 45 degrees. And I also know that if that's 45 degrees on this side, I'm going to put this, what I'm going to do here is kind of extend both of these like this. And if he continued on, alternate interior angles say if this is 45 here, and this is parallel and this continues on, you'd have a 45 there. But I'll get into that in a second. Let's just start with this. This is 45 degrees, and we want to know what distance and all that to travel here. So to work this out, I'm actually going to find the angle on this side. And so I was kind of messing up there on the second ago. Let me put that dotted back line back, go with this side. Alternate interior angles will put 45 degrees there. Now why does that matter? I know that's hard to see because this side is 90 and this side is also 45. So this angle right here, I'll call it, well, I'll just go like this. It's going to be 90 plus 45. So that equals 135 degrees. That's the angle that goes right there. That's 135. Now, if you look at this now, I don't have a completed set because I don't know this length across from it, but I can use the law of cosines because I have, from my unknown, I have the angle across from it. So looking at our formula chart, the law of cosine is given here. So I'm going to take this first one and say that a squared equals b squared plus c squared minus 2bc times the cosine of angle A. And so we'll start plugging in our values. Now we're looking for A here. That's what I'm going to call x squared. So my b, we could choose any one of them. I'll choose it to be 2 squared plus the c would become 3 squared. So times 2 here times 3 times the cosine of this 135 degree angle. And finally, to get x by itself, we'll actually take the square root. Normally, when you add a square root, you would do plus or minus, but since we're only dealing with positive distance here, we're going to just leave the answer as positive. So we're looking at 2 squared, which is 4, plus 3 squared, which is 9, minus, if you want to multiply this out, 2 times 2 is 4, times 3 is 12, 12 cosine of 135 degrees, which gives us this distance of 4.6 miles is what we'll call this. Now that's the distance. Now how could I come up with that angle here? Well, if we found this angle there, then I could take it away, this one and 45 away from 180 to find this angle there. So let's find this angle. And I'm going to use the law of sines this time because I now have a completed set. Now that I know what x is, now that we just discovered that this is 4.6, I have a completed set, and so I can solve for this angle using the 3 on the other side. So going back to the formula chart, I'm going to use the law of sines right there. And so I'm going to say that sine of my 135 degrees over my 4.6 miles is going to equal sine of the unknown angle. I've already used x, I'll just put theta, over 3. You could solve this. I'm going to cross multiply and divide. So we'll cross multiply that and have 3 sine of 135 degrees equals, cross multiply here, 4.6 sine theta. And now the two things to do to get sine theta by itself is first, or not to get sine theta by itself, this gets sine theta by itself, is to divide by 4.6. To break sine apart there, you'd have to take the sine inverse. And so what we're actually going to type in our calculator is sine inverse of 3 sine 135 degrees over 4.6. So come over here, trig sine inverse of 3 sine 135 degrees, degree symbol here, over 4.6, like that, and we get the value 27.46. I'm going to say 27.5 degrees, and that's going to equal our theta that we are looking for. So now that's that angle right there. This angle here is theta, which equals 27.5. So now if I want to know what this angle equals, what I'm going to do is, since all those add up to 180, is I'm going to take 180 and subtract 45 for right here, and then subtract 27.5 there, because all three of those, or this angle, and this angle should add to 180. So if I do that, I should have my answer. So I'll go 180 minus 45 minus 20. I'll just copy the answer real quick, or do Control Int. That we get 107.5 is the angle, 107.5 degrees. So those are our answers here. Felicia would need to walk 4.6 miles at 107.5 degrees.